right, classifying systems of equations. Like I said, this finishes last week's Thursday and Friday discussion up more than it does anything else. This information, you aren't asked this per se exactly like this in the midterm. You don't have to identify dependent, independent, inconsistent on the midterm, but I wanted to make sure that we closed our discussion up from last week. Remember, the first thing you have to do to a line before you graph it. What is the first thing you have to do to a linear equation?
Find the y.
Okay, you solve it for y. There are two major forms. There are two major forms of linear equations that we talked about. Slope-intercept form, which is y equals mx plus b. So if I put an equation in y equals mx plus b form, that's called slope-intercept. Again, remember the word that we used for the number in front of x, the slope, that coefficient of x, that was our slope, and then the constant sitting out there by itself was the y-intercept. So to take one of these equations and answer whether it was independent, dependent, or inconsistent, what would you need to do to each of these six equations down here before you graph them? Solve them for what?
For y.
Solve them for y. So guys, if I were to take the equation 3x minus 2y equals 2 and solve it for y, what would I move?
Negative 3x.
So I'd say negative 2y equals negative 3x plus 2. Then what would I do? Divide by negative 2. And I would get y equals 3 halves. A negative divided by a negative is a positive. 3 halves x minus 1. Okay. I would hope that some of you guys recognize this equation right here as standard form. Again, be careful of that though, because remember, standard form is having all integers and a being positive. See, this second equation right here isn't in standard form until you get a to be a positive number. Then once you have that, guys, you can always find the slope by doing negative a over b. So these two equations right here, they have in number one, in this problem right here, it's an example of a system that has different slopes. Different slopes. What does that mean the two lines are going to do?
Intersect.
They're going to intersect. And these three pictures up here, look up here please. And these three pictures, do these two lines in B, do these intersect? No. So I would expect that if I took these problems and I solved them for y, they would all have the same slope, but they would have different y-intercepts. They'd have different y-intercepts. Nice. And the same slope, different y-intercepts is a system that doesn't have a solution. Why does it not have a solution? Why does that system not have a solution? Because those two lines don't do what? They don't do what?
Intersect.
They don't intersect. Do these two lines intersect?
Yes.
Yeah. Those C intersects, so I would think that one would go with C. So one goes with C here. The reason one goes with the C is because I know those two lines cross because they have different slopes. How many lines are right here in A? How many lines do you see right there? We're solving systems, guys. We're solving systems of equations. Every problem has two equations in it. Why can't you see but one right here? Yeah, that's right. The other one is right there underneath it. There's a red line and a blue line right there. I can't see the blue one because the red one covers it up. Remember, one of the things that we studied last week is we said there was a time when you had dependent systems. And when you have dependent systems, that's when the slope, as the slope is 4 and the y-intercept is negative 3, if I took this equation right here and I solved it for y, That would be 8x minus 6, and then I would divide everything by 2, and even this equation, which it looks like they're different lines, those aren't different lines. Both of those, when you solve them for y, have the same slope, they have the same y-intercept. As a matter of fact, what really is going on there is number 2 is two lines that are right on top of each other, and the result is you only see, because the red one's on top, you only see the red one. And so if I had this, I only see that red line, which means number 2 is A. Okay, 2 is A. And then by process of elimination, 3 must be C. Again, the reason these two lines do not intersect and are examples of an inconsistent system is because they have, if you take both of these, guys, do it. Take both of these equations, solve them both for y. If you solve both of those equations for y, you'll find out they both have the same slope, negative 1/3, but one of them has a y-intercept of 2/3, and the other one has a y-intercept of 2. So they have same slope, different y-intercepts. Look at this red line in B. Are those slopes positive or negative? Look at the direction of it. Negative. See, that's what I said here. Y equals negative 1/3. So number 3 would be B.